this was an enormous historic event. Einstein's theory of general relativity predicted the existence of gravitational waves 100 years ago, and this is the first time that they've ever been detected. And that gives us a window into observing a lot of parts of the universe that we have no other way to see. So one of the ways that we've expanded our knowledge of the universe is to expand into different kinds of radiation that we can see. At first, we built telescopes and only looked in visible light. Then we built radio telescopes and microwave telescopes and X-ray telescopes and gamma ray telescopes and infrared telescopes, and each of these has allowed us to see sources that we couldn't see in visible light, or to learn more things about those sources. But all of those have their own limitations. So the detector, called LIGO for Laser Interferometry Gravitational Wave Observatory, consists of two perpendicular arms, each of which is about 2.5 miles long. And they're measuring when the length of one arm gets a little longer than the other. And then it switches. And they go back and forth. That tells them there's a gravity wave passing through. And in this particular event, the length of each arm changed by a few 10,000ths the diameter of a proton. In order to produce noticeable gravitational waves, you have to take an enormous mass and have it oscillate back and forth violently enough to send out these ripples. In the event that was recorded by LIGO, there were two black holes orbiting each other. As they orbit and they lose energy, they get closer and closer. And the reason they're losing energy is because they're emitting gravitational waves. And after a long, long time of orbiting each other, they have a quarter second of violently spiraling and colliding. And that's the event that we were actually able to witness. When we look out using light, we can see farther and farther back in time. If I look 1 billion light years away, I see what the universe looked like 1 billion years ago. And I can look 2 billion years ago, 3 billion years ago, 13 billion years ago. And a little bit after that, I hit a limit. And that limit is not all the way back at the Big Bang. Because for the first 400,000 years after the Big Bang, the universe was opaque. If we can measure gravity waves from the early universe, those have been freely passing through the universe back to the earliest times we know about. Now that's a big if. What do they look like? How strong are they? Are they strong enough for us to possibly detect today? We don't know. If we find them, that gives us a huge window into understanding the time right around the Big Bang.